Today I talk about this problem. How can you solve in MATLAB? So let's go. I define in here. This is the data file. So I define here number of node. So number of node is number 1, number 2, number 3, number 4, and number 5. So you may ask that why you define this as a node, why you define this as a node. This if you define this node as a node, then it will easy to define in MATLAB language. There is some load in here. I mean, there is a load. So if there is not any load, I will not define this is a node. And there is some section properties up to this, up to node number 3. There is section properties different, and with this. Okay, so number of node is 5 and number of element is 1, 2, 3, 4, and number of degree of freedom for each node is 2 again, and there is coordinate geometry. That means node number 1 is 0 0 coordinate, and node number 2 is 2 meter and y coordinate is 0. Node number 3 4 meter, y coordinate 0, and node number 4 7 meter, y coordinate 0. So in this way you can also define this thing. So here, as this y coordinate is 0, so I take that only one column. And element connectivity, so I make the connectivity matrix as zeros, so that there is no element in this there, and it depends on the number of element. So number of element and their connections. So number of element: 1 connect 2, 2 connect 3, 3 connect 4, 4 connect 5. For beam it's easy, but for truss there is some complexity. And now properties, again I make the properties. It depends on the number of element. So there I have to define two properties. One is E, one is I. So and the column is two number column. So properties here again, for this section, this and this, and for there the properties and change. And boundary condition in here, again there is a loop. There's counting of the free degree of freedoms in here, and their internal hinge, there is no internal hinges here. And joint load joint load is 0, and there is element load. Joint loads here at node number 2 we define its negative. We take the y positive here, upward is positive and downward is negative. And here at node number 3, you see here node number 3, node number 4, and node number 5 is the load is 0, so we didn't define it. And load number 3 here, the load is 7.5, 3.5, and I mean it decreases. And again here for at node number 4, the load is depend on the number distance multiply the uniform distributed load in here. So this is the data file. I divided it some sub file. So mainly I take this code from a book. It's called Introduction to MATLAB. And let's go this main file. This is, I call here this beam3 data file, load the input data file, and form some matrix in another also file. Go there, form kk. This is a matrix file, and this is force file, global force vector file, and this is beam k. It depends on the I mean it will rotate again and again. And there is a thing 12 vi by cube. It depends on the stiffness matrix. And there is a steering vector, and so this main file will call all of the file, and make a loops in here depend on the number of node, and it gives. So let's run it. Okay, so there is the forces, and it say that the beam3 results in txt. So go there, beam3 file. So here all of the result print in here. So this is fy1, fy2, m2, and other parameters. So that's it. If you like my video, please subscribe my channel. Thank you.